Hello everyone, this question is about differentiations. So this is implicit differentiation. We have the parametric equations of curve R, x in terms of t, y in terms of t, show that dy dx. So we're gonna need some MF19 formulas for differentiation. So for x equals t times e to the 2t, we have a multiplication, so we have to use the product rule. This is the product rule. The derivative of uv is, this is u prime v plus v prime u. So that's what we use here, u prime v plus v prime u. So let's say the u is t, which means the u prime is the derivative of t with respect to t, which is just 1, and the v is just the same. And for the v prime, this is v. So for the v prime, yeah, we use this rule here. The derivative of e to the x is e to the x, so the derivative of e to the 2t is e to the 2t, but we have to use the chain rule, so multiplied by the derivative of the power or the coefficient of the t here. So we have to multiply by 2 because of the chain rule. So if we factor out e to the 2t, we still have 1 plus 2t. Now for the y, yeah, we use the algebraic or the polynomial rule only. So we bring power down, so we have 2 times t, the new power is 1, so that's just 2t. And here we bring the power down, 1 times the new power is 0, which means it's just 1. And for this guy here, this is the same as t to the power of 0, so 0 times whatever is 0, so they disappear basically. So we have the dx dt, dy dt. Now we use this kind of chain rule formula here. So dy dx is the same as dy dt times dt dx, because just like fractions, if we cancel out, it is still dy dx. Now the dy dt is exactly like this, so just rewrite. For the dt dx, you gotta be careful because this is actually dx dt, not dt dx. So we have to use the reciprocal, so 1 over, and we can cancel out, and we get what we need to prove basically in this form. Now for the second part, hence show that the normal to the curve where t equals -1 passes through the point. Okay, so a normal means the negative reciprocal of the tangent. So the normal gradient is -1 over the tangent gradient, and the tangent gradient is of course the derivative, the dy dx. So from the first part, we have the x equals something, y equals something in terms of t. So when the t is -1, we can just plug in. We replace the t with -1, the t with -1, the t with -1, and we get minus e to the -2 or -1 over e squared. And for the y, we plug in -1, plug in -1, we get 1 minus 1 plus 3, which is 3. And for the dy dx, from the previous part, we know that this is the dy dx. We plug in -1, and so we get e squared. So now to find the normal equation, we use the y minus y1 formula, not in MF19 unfortunately. So we know that the normal gradient is 1 minus 1 over the tangent gradient. So this is the tangent gradient. The dy dx is tangent gradient in calculus. So we have the gradient and we have the point, which is x comma y. So now we use the y minus y1 formula. This is y1, this is x1, this is m. We plug in everything and we get the normal equation. So if you expand here, you simplify, and then you move the 3 to the right, so plus 3 to both sides, you get this y equals mx plus c form actually. So this is the m and this is the c actually. Now what we're looking for is, if you read the question, it says passes through the point 0, 3 minus 1 over e to the fourth. So we just have to plug in x equals 0. So if x equals 0, we're going to get 3 minus 1 over e to the fourth, which means this normal line here passes through the point 0, 3 minus 1 over e to the fourth, which is what we need to prove. Alright, that's it. I'll see you again next